Welcome to Spring Lib.
In this question, we have to find the tension in the part of the spring when the smaller pulley has its radius 5 semi and the moment of inertia also given, that is 0.1 kg meter square. Now first of all I am drawing the diagram for this question. This is our bigger pulley and this is smaller pulley, and this is the string which is connected on both the pulleys, and a mass is connected with this string. This is our mass. Let this is m. For this we have given, that is I1 is the moment of inertia of this and R1 is the radius of this pulley. For this pulley, let I2 is the moment of inertia and R2 is the radius of this bigger pulley. Now I am drawing the forces which acts on this system. One is the weight of this block, that is mg is acting downward. This tension in this string is let, that is T1, and tension in this part of string let, that is T2. So we have given data, that is mass of the block M is 2 kg. For smaller pulley we have given that moment of inertia I1 is 0.1 kg meter square. Radius of this pulley is R1 is 5 semi, or I can write it 0.05 meter. For bigger pulley I have moment of inertia, that is I2 is 2.2 kg meter square and its radius, that is R2 is 10 semi, or I can say 0.1 meter. Now from the free body diagram we have, for block I can write mg minus T1 is equals to mass into acceleration, that is Newton's first law. Let this is Newton's second law. Let this is our equation first. For smaller pulley we can write that net torque, that is T1 minus T2 into R1 is equals to I1 alpha. This is our equation second. And for bigger pulley I can write it that net torque for this pulley is T2 into R2, that will equals to I2 into alpha. This is our equation 3. Now we have to substitute the value of T2 in the equation 2. Now substitute the value of T2 in equation 2. We can find that T1 minus I2 alpha upon R2, this into multiplies R1 is equals to I1 alpha. From here we get T1, that will equals to I1 upon R1 square plus I2 upon R2 square into A. Now substitute this value of T1 into equation 1. In equation 1. So from equation 1 we get mg minus, this is I1 upon R1 square plus I2 upon R2 square into A is equals to ma. From here we get acceleration A, that is mg upon I1 upon R1 square plus I2 upon R2 square plus M. Now put all the data in this equation. So we get A is equals to 2 into 9.8 divides 0.1 upon 0.0025 plus 0.2 upon 0.01 plus 2. After solving this, we get acceleration A, that is 3.1, sorry, acceleration is 0.316 meter per second square. This is the acceleration of the block, but we have to calculate the tension in the string. So this tension is given by T2 is equals to I2 into A divided by R2 square. So this is 0.2 into 0.316 divides 0.01. So this is 6.32 Newton. So this is the tension in the string which connects both the pulleys. So this is our final answer.